Alright guys, I want to show you a couple of things they put up on Canvas. The updated homework sheet, I just finished it in here just a minute ago. Yesterday was insane, so I didn't have time. The important, well, everything's important on here, but I've changed some of the assignments, cut those down. Let me see, did that make it through? Yes. This used to be something every third one, now it's something every fifth one, right? I don't know if you guys can really see that, but so this is up on Canvas. If you need a hard copy, just come by, see me. There's the other extra credit stuff. I changed these assignments. I changed these assignments. You guys with me? So I updated that. If you already started working on this, fantastic. You're getting extra practice. That's awesome. And then you can keep going with the new assignment if you want to. I also put up here finally, as I had promised, the polar graph paper. Look how nice it is. And there's like several sheets in there, so you can just print that out for yourself. Yes? If you find other polar graph paper somewhere, or somebody has some that you know, or whatever, you can use whatever polar graph paper. This is my personal favorite that I found. And yes, it is weird to be human with a personal favorite polar graph paper, but that's my life. Okay. Any questions on that? So that's up in Canvas for you.
Why is there a blue one?
Why is there a what now?
A blue circle?
Oh, I think it's because is it the fifth one? 1, 2, 3, 4, 5. Yeah, they're trying to do like a hash mark instead of it's a blue thing for circles. Yeah. I don't know. Oh, we just finished. Let's take a look real quick. We just got into systems of equations. So we basically did 11. Let me get back here. 11.1 and started talking about 11.2 a little bit, I believe. Do I have that straight? Let's all find out together. Let's see. We are.
What did we go through yesterday?
So yesterday we talked about systems of equations, substitution, elimination method for systems of equations, graphing method, which is quickly bad because if the answer is not nice whole numbers, then screw the graphing method. So we have algebraic methods, substitution, elimination. Yeah, we started talking about 11.2 a bit. That's when I was talking about the walls and the ceiling as planes, which would be equations with 3 variables in it. So let me ask you real quick. If I said x equals 2, wouldn't that just live on a number line? So that would be like a part of a line, correct? If I said x plus y equals 2, isn't that a line in 2 dimensions? So I went from 1 dimension with 1 variable, 2 dimensions with 2 variables. So x plus y plus z, it should make sense that it's 3 dimensions, like a whole plane with 3 variables. Okay, maybe. Okay, maybe? Are you guys okay? Okay, all right. So today we're going to do some examples of this. Then we're going to talk a little bit about the matrix. And we're going to try to pretend that there is no spoon and all that kind of crap. Okay, good. You're good. Any questions from homework stuff? We'll do some examples of what we did yesterday real quick, just to catch everybody up. If you weren't here yesterday, I think it was yesterday, that I announced my decision to drop the lowest test grade. Is that right? I can't remember. But if you didn't know, that's what's going to happen. And that's reflected in the grade sheet summaries you got. Did everybody get their grade sheet summary? Okay. yesterday we kind of reviewed a couple of things you should have kind of worked with possibly before the substitution method. Let's do one example of each of those. So if I want to use substitution, oh, I should make this work. Would that be good if I make this work? That'll work. Okay. 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 Yeah, this will good. This will be good for both methods. So I want to use substitution method. The hell does that mean? Anybody? What's that mean? What does that mean? What am I going to do? Am I going to add the two equations together? What would that be? What method would that be? What would happen if I added those together? The y's we can't. That's the elimination method. So I'm not saying you can use that. Too bad. Haha. We're going to use that in a minute. I want to use substitution method. How much information did I just give you up there? 2. I gave you 2 pieces of information. I told you 2 things that X and Y do together, right? So a lot of times I think of this as a case, a detective case. Somebody gets murdered. What's the first thing you look for?
Evidence.
What's the first kind of thing you look for? Say again?
Evidence.
Evidence. Yes, right? Evidence is information, correct? So, for example, you start collecting alibis from people. You start seeing if the alibis work with each other. You guys kind of with me? All right, I'm not suddenly big on to make this an AOJ class. Don't worry. So I have 2 things I don't know. Maybe that's the what time of day and the how did the person die, right? And I have 2 pieces of information. So in mathematics, for everything I don't know, I need that much more information. Okay, I like it. So for example, if I had 1 thing I don't know, do you need another equation to be able to figure out what X is? Can you figure out what X is? Yeah, I just need 1 piece of information because there's 1 thing I don't know. Yes? Okay, I like it. So, pick one of those 2 equations. What variable can you solve for pretty easily? Y. Exactly. If you try to solve for X, don't you make funky fractions? And you should be able to handle the fractions if you had to, but if you have a choice, holy shit. I'm not going to work with them either, because I'm a human, and humans make mistakes with negatives and fractions. Okay. All right, which equation do you guys want to solve for y?
Number 2.
Okay, cool. How do I solve number 2 for y?
Y equals 19 minus 6.
Yeah, subtract. Oh my god. Subtract. Oh, I think you're going to be just as bad, Blue. All right, you're not that bad. Subtract 6x. So I get y equals 19 minus 6x. Is that cool? You're a little bad, Blue. Down to like 1 thing that's working. So this is the new equation 2. Is that cool? Same equation, just rewritten. So wherever in this universe that I see y, what can I replace it with?
19 minus 6.
19 minus 6x. So how can I rewrite the first equation? You do it that way. This is 4x minus.
19 minus 6.
I'm going to make a mistake. I just made a mistake. I have made a mistake. Can anyone see the mistake I made? What is the mistake I made? I see a few people saying yes. They're saying yes, Jeff. You made a freaking mistake. Don't you know math? What mistake did I make?
You have to put in a parentheses.
Yes. What am I subtracting? I'm subtracting y, and y is this whole damn thing, correct? This is a really easy mistake to make. You got to subtract y. Okay. All right. Solve that for x real quick for me. right? Distribute that negative, of course. You guys get 3? Sweet. Am I done? Do I circle that and keep going? What's the answer to a system of equations with 2 variables? What does it look like? A point, right? Because when the graphical interpretation is one equation would be a line if I graphed it, the other equation would be another line. A line has all the answers to that equation, so what answers both equations? Where those 2 lines meet. That's the one point that works in both. I like it. So, how do I figure out what y is? Well, don't I have a little beautiful equation right there? Once I know what x is, 19 minus 18, I get 1. So what is the answer? It's okay if you do this. I'm actually okay with this. If you circle x and y. Technically, what should the answer be? What is it? Sorry? 3 comma 1. X, y. Yeah, it's a point. Okay, I like it. All right. Okay. So, how does elimination work?
All right, you are a lot of work for a bad marker. All right.
Yeah.
You're green. You gonna work?
Yes. So elimination. This is the way that I prefer, because I'm weird. I like to kill these things, these little variables. Come here. I love them and I want to kill them at the same time. It's crazy. So we already covered this. Do you guys remember why I'm allowed to add 2 equations together? It should trouble you that we suddenly start doing that. Why am I allowed to add 2 equations together? If I ask you that, could you tell me? Because I'm going to add these together. What am I adding to this side if I add these 2 equations together? What am I adding to 11? 19. Am I not supposed to add the same thing to the other side? But 19 is this. So if I add 19 to 11, I can add this to this, and I'm adding the same thing to both sides. That's why I'm allowed to add 2 equations together. So let's see what I get. I get 4x and 6x. What the y's cancel. Do you see why I like this method better? Didn't we get 10x equals 30 over here? After some work, yes? Didn't I just get it like immediately? Okay. And then I divide by 10. X is 3, and then I throw 3 back in. I get y is 1. Of course, we already did the work. Is that cool? Maybe? All right. Which equation do you throw 3 back into? Kind of a trick question. Should it matter which equation you throw 3? Because that's where they both meet. So it doesn't matter which equation you put 3 in. Right? This would be 12 minus what is 11? 1. What plus 18 is not 1. So either when you put it in, you're going to get 1, of course. Let me stop for a minute. Compared to some stuff we've done in this class, this is pretty straightforward. Right? Now you might notice that this is from 11.1, and Jeff very evilly did assign anything from like what? Sorry. So this is just review. This should just be review. So here's the real stuff. Okay. So the real stuff is, in real life, in a murder case, for example, how many unknowns are there? I don't need a specific number, but just kind of tell me, are there going to be like 2 unknowns in a murder case? There's going to be a lot of freaking unknowns, correct? That's why it takes forever. They're trying to develop more information and putting the things together, right? Okay, maybe. So real quick, I got a dumb example in my head. Let's say somebody tells me Bubba came out of the store at 3 a.m. And we're like, okay, that's good to know because the murder happened at 3:05 right outside the store, but who the shit's Bubba? What? And then later you find out, oh yeah, Jim goes by the nickname Bubba. Is that new information? Can't somebody replace this with Jim now? Oh, okay, now I got something on Jim. Get over here. I don't know. You guys understand? That's a really dumb example, but okay, sorry. So that's a substitution method in real life. All right. Now, let me do this. You and I are going to create a problem together. We're going to start with the answer. It's going to be. I like to do this with students because so we already know the answer to begin with, right? This kind of shows you how I make some problems. I start with the answer and then I make the problem, so I know it's going to work. You guys with me? I really want you guys to see this. Somebody help me out. An answer. If I have 3 variables, the answer has to have how many parts to it? 3, right? I need to know what X is, what Y is, what Z is. Or it could be A, B, C. It could be any letters. Somebody give me what X is. A number. Give me a number. I love you so much. But that's not a number. Sorry. It's a process. 3. Okay. Good try, Christian. Somebody else give me a negative number for Y.
Negative 5.
Did you give me 3? Okay.
Negative 5.
Somebody else give me a number for Z. 7. Thank you. This is X, Y, Z. That is going to be the answer to this system of equations. Now, this is not the way you're going to have these problems, correct? I'm going to give you the answer first because you'll go circle, done. Next, right? I just want you to see what this looks like getting put together. If that's true, what is X plus Y plus Z? 5, yes? 3 and 7 is 10, minus 5 is 5. Does everybody see that? That's just what that is. Now take a minute and think about this. What is 2x plus 3y minus z? Negative 16. You guys with me? How many of these could I do? Infinite, yes? 4x plus blah blah, 5x plus blah blah, 6x plus blah blah blah. Yeah, holy shit. Okay, well, we only need how many to actually be able to work the problem out? We just need 3. So let's do one more. Let's see. Let's do negative x plus 5y plus 6z. Ooh, yeah. I like it. Does everyone see where we're getting these numbers from, right? So help me out. Who's got this? I think I got it.
24?
Huh?
24?
I think it's 14, but I could have done it wrong in my head. Let's see. Negative 3 minus 25 is negative 28 plus 42. That's 14. Does that work with anybody? Anybody else doing that for me? No? You guys are all like, somebody's gonna do it. Okay. More Z. Okay, so. 3, -5, 7, we know the answer already, but you're not gonna see that. You're just gonna see this. So these are 3 distinct pieces of information that we've collected in the murder of W, right? X, Y, Z are suspects. You with me? Okay, maybe. So what the shit? What the shit do I do? We know what to do if there's 2 variables. That's fantastic. If there's 2 variables, I can substitute, I can eliminate, right? I got 3 variables. Shit! Can somebody tell me, looking at all these things, which variables might be a good ones to cancel? Which ones would cancel immediately if I added 2 of these together? So let me see. 1, 2, 3, right? Do you see a variable that if I add 2 of those together, it disappears? X. Did anyone else see another variable? Z. So either one of those I could use immediately, right? And tell me this. What sucks about these equations? Why are these equations worse than those equations? Why are these worse than those? Because these have one more freaking unknown, yes? The more unknowns, the worse the situation. Does everybody agree with me? You walk into a forest and you're like, rodents of unusual size, do they exist? Where's the fire pits? What's going on? All these unknowns, I don't know, right? I'd rather have fewer unknowns. Okay, so which 2 equations do I add together to just kill X? Right off the bat, let's kill X.
1 and 3.
1 and 3. So what I'm going to do for myself, I'm going to tell myself what the shit I'm doing, right? I'm going to add 1 and 3. Now 1 plus 3 happens to be 4, but then I'm going to make a 4th equation. Are you guys with me? So it could be 2 plus 3 makes a 4th equation. So what do I get when I add 1 and 3? The x's cancel, right? Add 1 and 3, what do I get?
6y.
6y. Plus 7z. All right, 7. Calm down.
9.
All right. That equation is much better than any of the other 3 because it has less unknowns. Makes total sense. But, Jeff, good? Good for you, math person? So what I want is, I want another equation that has only y and z, because weren't these relatively easy? Because there's only 2, but I had 2 of them. Do I have another equation right now that has only y and z in it? No. How do I make another equation that has only y and z in it? Could I use these 2 to kill x again? If I add these right now, does x die? No. You guys see that? If I add these right now, x does not die. So what should I do to this first? So that when I add them, x actually dies. What do I wish was here? A -2, right? So let's take 3 and let's multiply it by 2. Do you guys see what's happening? You pick a letter, you take 2 equations, you kill the letter. You pick 2 other equations, and you kill the letter again. Okay, here we go. What's twice 3? What do I get? Twice this. I get -2x, 10y, 12z, 20, 8. And I want to add that to number 2, right? So let me just put number 2 down here. 2x plus 3y minus z, -16. So if I add those together, and I know right now some of you guys are like tuning out. You're not used to problems that are a little bit longer. At some point you're like, okay, we should be done with this problem by now. We're not, so screw this problem. But the steps we're taking are not difficult. It's a little longer, I agree with you, but they're not difficult. Now again, I know 2 plus 3 is 5, but I'm making a fifth equation no matter what, okay? Now making a fifth equation, what's that fifth equation gonna be? 13y plus 11z equals 12. Oh, this is a good one. Ooh, this is a gross one, I like it. Only math people get excited when the problem is gross. I have 5 equations up there, don't I? Which 2 are the best? 4 and 5. So let's see, 4 is 6y plus 7z. Jeff? 7z. And 5 is 13y plus 11z equals 12. Okay, I love it. I didn't mean for this to come out so gross, but I love it. If I add those together, does anything die? See, now I forget where I came from, and that's where I am. I want to make one of the letters die, of course, right? Now, all right, I kind of want to show you something really cool. Nothing dies, right? And in fact, can I just like double this and then something's going to die? No. What do I have to do then? How do I make the things die? If I wanted to kill the y's, let me see you guys. It's the same idea as LCD. What's the LCD of 6 and 13? 6 times 13, right? There's that. So I'd have to multiply this one by 13 and this one by -6. One of them has to be -6. What do I remember? What's my goal? What would make 2 letters die if one was the exact negative of the other one? Yes? So if I have a 3x, I want a -3x. You with me so far? So it's awesome if I have like x and 3x, I can just multiply this one by -3. Easy. Neither one of these is 1. Neither one of these is 1. And in fact, if that was a 12, that would be awesome, wouldn't it? If that was a 12, I would just multiply this by -2. But it ain't. Damn it. So let's see if I can get you guys to understand this right now. What is the best coefficient to see? What number would be the best coefficient? I love it. I was wondering if anybody would say 0. That would be the best. But yeah, 1 would kick so much ass. Do you understand? 1 is the best, because then if I need it to be a 3, multiply by -3. I need it to be 11, multiply by 11, right? So let me show you. All right, I want to do both ways. Let me see. So real quick, if I multiply this one by -13, and I multiply this one by 6, they'll both become the same number, but opposite signs, right? And we all have calculators, so who cares? So what is 6 times -13?
78.
Yes, so it'd be -78. 7 times -13? 91. 19 times -13? -247? Anybody? Nobody gonna help me? -247? Okay. Go, Jeff. All right. And then I multiply 6 times this, that'll be 78. Of course it is, because that's how we built it, right? We're not surprised by that. 11 times 6 is 66. 12 times 6 is 72. All right, let's see if I made something that actually works here. Isn't that gross? Is it very great, man? It's gross. Is it hard? No. You just freaking multiply, right? So these cancel. -91 plus 66 is? -25. -247 plus 72. 1 175, right? Okay. And look, hey, wait a minute, let's see it. All right, how do I solve for z? Divide. So z is 7. Am I done? Shit. All right. Now it's dominoes. Right? Not the pizza. Dominoes is dominoes. What do I mean by that? The minute I know one variable, I fall back. And now I can figure out y, right? Because now I know 6y plus 7 times 7 equals 19. So 6y equals 30. So y is everybody cool with that? I know z is 7. 7 times 7 is 49, right? So now I can solve for y. 6y is 30, correct? I'm sorry, negative 30. Is that what you guys? So subtract 49, negative 30. So what's y? Negative 5. So now I have 2 of the variables. Am I done? No, damn it, shit. All right, so I'm gonna use the first one here. See, I don't know what x is, but I know y is negative 5, and I know z is 7. So I get x plus 2 is 5, so I get x is 3. Does that match up with how we created this? So again, it's not magic. It's like we made it. That's the answer, right? 3, negative 5, 7. How many people did not enjoy this step? Everybody like this step? That's awesome. I love it. Everybody loved this step. Cool. All right. It's good to know. Nobody disliked this step. Everybody loved it. Okay, I won't show you a shortcut. No worries. Anyone want to see an alternate way to do it? That's better? Okay, a few of you guys. Okay. So real quick. This is done. This is done, correct? I'm just going to show you an alternate way you could have done right here. So let me recapture this. All right, I'm going to do something stupid. Not stupid. I'm going to do something that doesn't immediately make sense. Let me see if you guys catch on. I'm going to multiply this one by negative 2. Where am I at? So cool, I just multiplied number 4 by negative 2. I can do that. I can multiply them by 11. I can multiply them by the square root of 149. I can multiply whatever shit I want to except 0. Right? So you're like, go ahead, math boy. Have fun with your numbers. What do I get now if I add these two together? Why?
Minus 3z.
Minus 3z. Negative 26, thank you. Right? Why is that better? Because there's a, try this again, there's a 1, right? Again, done, yes? Done. We did it, we're done. Alternate method if you want. I just made a 1, right? So can't I take this one? Yeah. And multiply it. Well, that's not my thing. All right. I just made another equation. So let's take this one and multiply. Sorry. Let's take this one here. Calm down, John. And multiply by negative 6, because then that'll kill this. You see that? So it'll be negative 6y plus 18z equals negative 6 times this is 156. Is that true? What is it? 6? 120? Yeah, okay. So now if I add that to 4, let's see if I get the same answer. If I add these together, these die, 25z equals 135. 20, oh, no, Jeff, come on, you can do better than that. You're adding, my friend. Yeah, 175, same thing we got before, okay. Again, we're done here, we're done. You don't ever have to do what I just did, but if you see gross things like this and you're like, all right, I can get a 1. If you can make a 1 show up, that's beautiful. You just multiply it by whatever you need it to be. Or just do the LCD idea like we did here. If I multiply each of them by the other guy, they become the same number. Maybe. Your whole goal is to take the 2, make them work together to kill one of the letters. That's all I care about. And there's multiple ways to do that. Okay, maybe. That's all there is to it. I mean, I cut the homework down in that section because, I mean, you do a few of these problems and you're like, I get it, Jeff. Right? There is so now we're going to talk about the ultimate shortcut to this. Right? I mean, this was kind of like another method, but it didn't really make it quicker. Right? It just made it kind of easier to think about. There is a shortcut to this whole process. I mean, look at all this that we wrote. That's a lot of writing. It's a lot of keeping track of things. You're initially not going to be terribly excited about this because it's a new thing. But once you work with it a bit, you start to see the utility of it. And I gave it away earlier. Right? Has anybody ever worked with matrices before? Working with a matrix, one person? Yes, a few people? Okay. Can somebody, all right, so let me write a matrix up here. You want the 1. Purple, you're my best marker. So here's an example of a matrix. Woo! That's an example of a matrix. Have any of you guys ever used Excel spreadsheet stuff? Yes. Excel lives on matrices. Do you see how the matrix has rows, right? This has 2 rows and 2 columns. Isn't freaking Excel rows and columns of shit? Yes. So this could be, I don't know, last year, this year, number of TVs sold, and whatever, I don't know. Right, whatever the shit somebody's doing with Excel. You can tell I don't teach business. I hate business. Okay. Business has its place, sorry. If you're majoring in business, you're fine. It's just not my thing. Okay. So some people have seen this kind of thing, I guess, right? This is what we call a 2x2 matrix. It's also what's known as a square matrix. Because it's the same both ways. Rows and columns are the same, right? Now this is hiding something. Here's another matrix. What do you think that is? Is it square? Hell no. So here's how the something by something works. It's always the number of rows by the number of columns. It's always rows by columns. How many rows are there? 2 by 3. So it's sort of like talking about pieces of lumber. You get a 2 by 4 and so on. Okay, I like it. Unfortunately, I mean, we don't have a lot of time, so we're not going to get too deep into these things. These are mathematical objects, the same way that the number 5. You wouldn't describe it like this because you're not as weird as me, but the number 5 is a mathematical object. It's a thing that I can do math with. I can do other shit with it too, but fundamentally, it's a mathematical concept, right? It's enumerating how many objects are somewhere. Different civilizations had different symbols for 5, right? Real quick, the Mayans, the way that they would write 5 is this. That's 5. The way they would write 6 would be this. So each line is 5 and each little thing is 1. You guys semi with me? So I like the Mayans because they have, it looks like pancakes and blueberries. I always call it pancakes and blueberries, but, okay, maybe.
Is 8 with 3 dots?
Say again?
Is 8 with 3 dots?
8 would be 3 dots, yeah. So this would be 8. Yes.
Isn't that
Right.
also like infinity?
Huh?
Isn't that also infinity?
Is that infinity? I mean, if you lay down.
The Mayans.
Huh?
That's for the Mayans.
Maybe, I don't know. I don't
It's
think
like some sort of spiritual.
Well, here's something really weird. Have any of you guys ever been inside of Chipotle? All right. If you've never been inside of Chipotle, you're doing pretty good. All right. Don't let them fool you. It ain't healthy. All right. But, you know, a Chipotle every now and again won't kill you, but it's not going to make you feel good. Sorry, Chipotle. Whatever. Copyright. Yeah. All right. If you've ever been inside, there's this wall art on most of the Chipotles. I only know this because I used to grade papers in the corner bakery, and across the way was a Chipotle, and I could see inside. I'm like, wait a minute. And sure enough, it's the Mayan god that's a symbol for a number. So they have these like everyday symbols, and then they have these really intricate gods that represent different numbers. So I was like, oh, okay, that's neat. All right, some math on the wall of Chipotle. Why not? Right? Okay. All right, I'll stop. Okay. I really went off on a tangent. So let me just put a problem up here and see what you guys think. What is 4, -2, 5, 1 plus 3, 5, -2, 6? What do you hope that would be? Come on, you guys can do it. You guys can do it. What do you hope it would be? Here, I'll tell you, what do you hope is going to go in there? Nobody? You're all like, I hope you tell us this is a joke and we're not doing this weird shit. No. What do you hope goes right there? 7, and it does. That's exactly how these work. Isn't that nice? So what goes here? 3, holy shit. What goes here? 3. And what goes there? 7. I wish you could take credit for that. I didn't think ahead. It's just a coincidence that it came out to be like that. That's kind of neat, nice symmetrics thing. All right, so matrix addition works the way you would hope. Matrix multiplication does not, but we'll get to that in a minute. So let me ask you this. If I call this matrix A, so we normally use capital letters for matrices, and I call this matrix B, what do you think about A plus B? What do you think happens there? Does anyone see kind of an issue? A plus B.
0.
Huh? 0? No?
You wouldn't be able to do it.
Say again?
You wouldn't be able to do it.
Exactly. Why not?
One is 2 by 2, the other is 2 by 2.
Yes, this is missing a column. This isn't just 0. This is like the end of the universe here. In terms of this matrix, this is all it knows. And then this guy's like, oh, there's shit beyond it. And this guy, oh, what the flip? So you can only, this is kind of beautiful. It's kind of like the idea of like terms. You can only add like dimensional matrices. So I can add a 2 by 2 to a 2 by 2. I can add a 2 by 3 to a 2 by 3. I cannot add a 2 by 2 to a 2 by 3. That doesn't make sense. This isn't just 0 here. There's nothing there. Not 0. 0 is something. There is nothing. The universe ends here. So when it sees that, it's like, what? Spheres with corners. You know, I don't know. It's beyond its comprehension. So yeah, it can't do. Or undefined. Or ha ha ha. Or, you know, can't do that. Okay, maybe. Okay, so Let's see, yeah, we got time. So let's try matrix multiplication. Okay, this is where things get really crazy. All right, we'll start with some nice 2x2s. There were options for how to define multiplication. We chose the option that made the most sense in general. It's not going to make sense immediately to us because we don't know everything matrices can do. But this is sort of related to a lot of the things that Excel spreadsheets do. They do something very similar to this because they're built on matrices. So let's see, let's do, let's just make a nice little matrix, nothing too crazy. 1, 2, -3, 4, sure. Times 5, -1, 2, 1. Okay, nothing too crazy. Now what you hope would happen is not what happens. Because what you hope would happen is not useful. And again, you'll have to get further with matrices to really see the full reason that's true. I think there's a few examples I can give you. I've got to think about it, about why this makes more sense. So here's how matrix multiplication works. What size is this? 2 by 2. What size is this? 2 by 2. Okay. That's going to become important in a minute. Here's how matrix multiplication works. What's the first row of the first matrix? 1, 2. Is everybody cool with that? What's the first column of the second matrix? 5 2s. Everybody see that? First row, first column. Right? So here's how this works. It's sort of like distribution, but not really. What is 1 times 5?
5.
What is 2 times 2? So 5 plus 4. Right? In fact, let me ask you this. So the answer, I'll tell you this, the answer is going to have 4 parts. Do you see how this part is made from the first row, first column? Because this is the first row, first column element. What element is this? This is the element that's in the first row, second column. So how do I create it? First row times the second column. What's 1 times -1? And what's 2 times 1?
2.
So you do this times this. 1 times -1 plus 2 times 1. To be really honest, there was a section we skipped that was all about vectors. And I felt like I could skip that because if you go into physics and all that, they're going to really tell you about vectors, and it's all built off of trig, so you should be able to kind of put those together when you get there. Matrices are vectors, like multiple vectors. Here's a vector, there's a vector, here's a vector, everywhere's a vector. So matrices hold a lot of information at once. Let's see. What about, how do I get this element? What element is this? Second row, first column. Second row, first column. -15 plus 8. And of course, this is the second row, second column, second row, second column. -3 times -1 is 3. 4 times 1 is 4. So what's my answer? 9, 1, -7, 7. How you guys doing right now? If you're not out there going, why the hell did you people define matrix multiplication this way? Well, because that's what makes it work the best. And believe me, that's not the only matrix multiplication that we have. It's the most basic one. So let me ask you this. Let me see if anybody gets this. If I wanted to multiply 1, 2, negative 3, 4, but I want to multiply it by 5, 1, 6, negative 1, 2, negative 3. Will that work? When I multiply this times, oh shit, what happens? If I try to multiply this by this, like exactly like we did, right? What happens? 1 times 5, 2 times 1, outside the universe times 6. You guys see that? What are the dimensions of this? 2 by 2. What's the dimensions of this? 3 by 2. Matrix multiplication will only work if the number of columns here matches the number of rows there. Because, do you see how it's got to have somebody to go with? Do you guys see that? So if the number of columns here does not match the number of rows there, you can't do it. So since 2 and 3 are not the same, can't be done.
Is a row horizontal or vertical?
There are 3 rows here. See that? So that's 1 row, 2 rows, 3 rows. And then there's 2 columns. That's why it's a 3 by 2. Row by column. Yeah. All right, so here, let me give you guys one to try. Let's give you a couple 2 by 2s. 2 by 2. Let me see if I can make it special. Yeah. Maybe. Stop. I'm trying to do something special. Yeah, that would work, but then that would be, I can't remember, shoot. Let me see if I get this right. Nah, screw it, just make something, Jeff, okay. Trying to make something happen, but it doesn't matter. Okay. All right, do that real quick. Why are you able to do this? Because these 2 here match, right? So go ahead and multiply those together. That's true. That is true. You could, like, on your paper, you could be nice to, you could do this, right? So I want the first row, first column, to get the first row, first column elements. So we get negative 10 plus 28, right? Is that cool? negative 10 plus 28. So I get 18. So you guys got? Yep. So now I want on this one, I just do first row times second column. 5 times 1, 5, plus 7 times 3, 21. 5 plus 21, 26. And then I want second row, first column, negative 4 plus 12. And then I want second row, second column, 2 plus 9. Does that look good? All right, so let me show you real quickly. Oh, yeah, I got that. Well, now that I can, no. Yeehaw. If you want to know how to get this for your own computer, just pay a lot of money. It's a little evil. I always have students like, how do you get that TI calculator on your computer? Pay a lot of money. All right. Oh yeah, look at that. So let's see here. Now watch this. Anybody see a button on the calculator that seems like it would be useful in this section?
Second over X.
Yeah. You see right up here it says matrix. So if you have a calculator, hit second, x to the negative 1, you get some weird shit. So these are just names of matrices. I want to edit one of these matrices. Okay. If I want to put this problem in there, I'm going to call that first one A and that second one B. Is that cool? So of course I want this to be 2 by 2. And then I just put it in. 5, 7, 2, 3. Woo-hoo. So then I go back. I hit second matrix again. And now I go over to edit. And now I'm going to edit B. So now I'm going to put 2 by 2. And then I'm going to put negative 2. 1, 4, 3. Shabam! How you guys doing? So now I go back to matrix, second matrix. Names, look what happens if I hit enter, it just picks it. Shit, I forgot to get out of there. Damn it, everybody hit second mode, quit, get out. Sorry. These calculators are not built to access the matrices quickly. You go in and then you have to quit to get back out. It's crazy. So let's try this again. So go to matrix and I pick A times, go to matrix and I pick B. Look at that shit. Yay! So you have a way to check your work. You have a way to check your work. You're welcome. Let's see what it does. Watch this. Let's see what it does. Real quick. Hold on. What was that? Shit. All right. Hold on. Let me do something real quick. Let's see if I can do it. No, Jeff. There you go, buddy. Let me edit. Let me edit this guy to make it a 2 by 3. And it doesn't matter what these are. Let's just leave that at 0, make that a 5. If I try to do this now, so that's a, what did I do? What have I done? A 2 by 3 times a 2 by 2, should that work?
No.
Because the inner ones don't match, right? So see what this poor little calculator does. If I hit second enter, I'm going to tell it to do the same thing. But now it's a 2 by 2 times a, 2 by 3 times a 2 by 2. It shouldn't work. Hey, dimension mismatch. Hey, that makes sense. The error message makes sense. It just don't work. Let me see what it does if I say go to. Oh yeah, so there it just says, hey, this matrix is not the same size. You guys with me? So that's the same thing as undefined or can't do or whatever. That's how the calculator says it. All right. You could also do I can't do it now. Let me see. If I try to do a plus b, will it be able to do it? Remember, I changed this to be a 2 by 3, so it's going to have the same problem, right? Okay, anyway, sorry. That's enough. So yes, you can do matrix stuff in your calculator, thank the gods. All right. So I've cut out a lot of stuff with the matrices. The one big thing we're going to do with these matrices is we're going to make a game out of solving systems of equations. Remember that thing we did earlier with the detective and the murder and the X, Y, Z shit, right? Mm-hmm. Wasn't it a little bit gross trying to keep track of everything? A little bit? Now some of you guys might be smart and go, no, it's Jeff, I'm fine with it, man, I'm fine with it. Just cut that section out. I'm fine. Give it to me. I want you to understand something. Do you understand if I had x plus y plus z plus w plus a plus b plus c plus d equals 2. How many more equations will I need to be able to solve this? 1, 2, 3, 4, 5, 6, 7, 8. How many more equations do I need? 7 more. I've already got 1, right? Is everybody with me? Can you imagine trying to solve this by hand? In fact, let me cut it down. Let me cut it down to 4. Okay. If I have a system of equations with 4 unknowns, I have to pick a letter, kill it 3 times. Then between those 3, I have to pick another letter, kill it twice. And then I can finally do, oh my God. So the minute I add 1 more unknown, this process grows quickly in terms of how much work I've got to frickin' do. Shit. And in any given situation, think about predicting the weather. How many variables do you think there might be involved in trying to do that? 3? 4? I mean, I'm not asking you for a number. I'm asking you, how many do you think there are? Is there just a few? There's a frickin' lot, right? And we are continuously learning other variables and more relationships between the variables, and that's why our predictive powers are getting a little bit better, right? Well, compared to like 1960, when they're like a hurricane's out there somewhere. Good luck. And now at least it's like the cone. I know we live in California. I'm well aware we don't get hurricanes, but I used to live in Florida, Virginia, and we'd have the cone of uncertainty, and we're all like, come on, hurricane turn. Or when I was little, I'm like, come on, hurricane, close the school down. You know, that's exactly, I sound like Mickey Mouse. Okay. So I want a process that is relatively the same amount of work, no matter how many freaking unknowns I've got. That would be so cool. I'm trying to sell you on this. All right. So, here's the thing. So let me, oh shit, let me see if I can make one real quick that works. I'm gonna make it easy on myself. Okay, yeah, that'll work then. Okay, I think that'll work. Okay, we'll find it. All right, so this by itself is kind of already bad, right? And the amount of work I have to do. Can somebody tell me really quickly, which letter would you most likely start to attack?
Z.
What determined that for you? Why don't you want to work with X or Y?
They don't equal 0 when you add them together.
Say again?
They don't equal 0 when you add them together.
Okay, good. What if this was, I don't want to change. What if there was a 3 there, but there was a -2 here, right? If there was a 3 here, don't change that. If there's a 3 there, I would work with the x's because then the coefficients work well together, yes? So your answer is correct, but it's because of the coefficients. These coefficients work beautifully together, And then I could just multiply him by 5, so these would kill, right? It's the coefficients that tell me everything. I don't know how you feel about this, but this is going to be a little bit like synthetic division. Can you guys tell me, do you like long division or synthetic division? Which one's better?
Synthetic.
Let me ask you this. Do you remember long division and synthetic division? Which one was better?
Synthetic.
Because there was a lot less writing, correct? And what did we do with synthetic? Didn't we eliminate the letter? We just put the coefficients, right? Because the coefficients were what's telling us same thing. So look what I'm going to do. Look what I can do. I can convert this into a matrix. What are the coefficients here? Yeah, 1, 1, 1. I put a line for the equals. 4. Is that cool? You guys see that? So just collecting the coefficients. Here. 2, 3,
Negative 1.
-1, 3. 3,
Negative 4.
-4, 5, 9. Okay. The line, some teachers don't show that. I like to put the line to remind me that's where the equals is. So what's the first column represent? You can do it. What's the first column represent?
X plus 5 plus 3 plus 1.
The first column, sorry.
Oh.
First column is all the x's, yes? What's the second column?
Y.
Y's. What's the third column? Z's. And what's the last column? Answers. Okay. Can somebody tell me? All right, now watch this. Watch this. Can somebody tell me if this looked like this? Why would this be so cool? Why is that so kick-ass? Can somebody interpret that first row for me?
X equals 3.
X plus no y plus no z equals 3. X equals 3. Y equals -4. Z equals 5. So if I can make this look like this, I can just read the answers off. Why are the zeros so cool? Why are the zeros so nice? No, I'm gonna say cool. Look at them kids, they're cool. Why are the zeros so nice? What does a 0 mean? There's none of that variable. And what are we trying to do? Aren't we trying to kill the variables? There's too many of them. Maybe. Maybe. It's like gophers out in your yard. Like, God, never too many dead gophers. Or, I don't know. Try to remove them. Don't kill them. Try to take them somewhere else, but do what you have to. Okay. This here is called, oh my God, this is called row reduced echelon form. I don't care about the name that much. Row reduced echelon form. So, do you see how this has kind of been reduced? Would you agree that somebody could say this, if I can make it look like that, I've sort of reduced it? If you could sort of say, yeah, I've sort of made this look better, so it's sort of like reducing a fraction, right? Making it look lower terms, so forth. So you can see why somebody might call it reduced. There are rows that I'm working with, so row reduced. Echelon. Has anybody ever heard the word echelon before? You want to try to get into the upper echelons of athletics or something, right? So this is just tiers. Form. Okay. What are the coefficients? What are the first letters? R, R, E, F. That'll be very important in just a minute. R, R, E, F. Okay. Now let me ask you something. Okay, great. I'm going to erase this. Maybe I won't. What would the first step be if I was doing this by hand? What's the very first thing you would do? Come on, guys. Which letter would you want to kill? You told me earlier. Z's. How would you kill them? What's the very first thing you would do? Add equation 1 to equation 2. Where are those equations in here? row 1 to row 2, right? So here I could just add row 1 to row 2. Do you see how that relates? Do you see how right there I can see that would make a 0 here? So I'm taking this process and making it into some sort of admittedly lame, but still a game, right? I'm trying to make zeros, because if I make zeros, I'm killing some letters. There's too many damn variables. The number of variables is too damn high, right? So we're trying to kill some of them. Okay. So I'm trying to make zeros so I can make it look like this, so I can just read the damn answer off, right? That'd be awesome. Okay, so what am I allowed to do in this matrix? Anything I'm allowed to do with the equations, I can do with the matrix. So I can add 2 rows together, because I can add 2 equations together. How would you kill the z here? Multiply this row by 5. So if I could multiply an equation by 5, I can multiply a row by 5. So everything I can do here, I can do there, because that represents this. Okay, all right. Maybe. So let's try it. Here we go. All right. So let's first, I'm not going to rewrite them, they're right there. So what I always ask you to do, please, dear God, is tell me what the shit you're doing. So which rows are we going to add together? What did we say is a good first step? Row 1 plus row 2. The answer I get, is it a better equation than the 3 I've got? Remember that we talked about it earlier. What makes an equation better when it has less variables? So when I add those rows together, do I get a better equation? Yes. So what I'm going to do is I'm going to replace a row with my answer because it's a better equation. I just want to keep track of the good equations. So I'm going to add row 1 to row 2, and I'm going to put the answer in, it doesn't really matter, Jeff, but we'll put it into row 2. Okay. And again, this is our first time doing this. So let's see how this works. So row 1 is going to stay the same. Row 3 is going to stay the same. But now I'm going to add row 1 and row 2 and replace that row 2 with it. So what is row 1 plus row 2? 3, 4, 0, 7, 11. Well, that's intriguing. I like that. Now, real quick, something just happened that I couldn't predict because I just totally made this shit up. But I desperately need you to hear me right now. Do you guys see that something else could kill each other right now? When you're still learning this, the worst thing in the world is to lose a 0. Does that make sense? I'm trying to make zeros, correct? So if I do something and it's not a 0 anymore, didn't I just kind of go backwards? So in order to make sure that doesn't happen, I try to tell students, finish a column and then move to the next column, right? So don't I want, well, this will work out. This will work out beautifully. What is my goal again? Isn't my goal this? Didn't I just get one step closer to that goal? Didn't I get a 0 there? So in this column, where else do I want a 0? I already got it in these row 2s, right? There's a 0, I got it. Where else do I want a 0? Here, right? Okay, good. So how do I make this become 0? Don't I just have a 5 there? All right, I really want you guys to see. 1s are kind of nice. They're not crucial, but they're nice because they can be anything I want them to be easy, right? How do you make a 6 become 7? How do you make a 1 become 7? Multiply by 7. So 1s are nice. So what would I multiply this by? So then when I add these two rows together, I get a 0 here. -5. So I'm going to take 5 times row 1. I'm sorry, -5 times row 1. I'm going to add it to row 3. But where am I going to put my answer? Where did I want the 0 to show up? I want it to show up right there, right? Put it into row 1. Now, real quick, this first time we're doing this is going to take a long time because I'm showing you like a lot of steps wrong. There's so many ways to make this process quicker. I don't know if anybody's catching on that this really makes it nice. I'm just trying to make zeros. So this makes it a game instead of this keep track of X and Z and Y and what the shit. I don't know if anybody agrees with me yet. So do you see how row 1's going to change? So let me do one little thing that's going to make this nice. I want to multiply row 1 by -5, correct? I don't want to write the damn matrix over and over and over again. So look what I can do. I'm going to put right next to this what it would become. 1 times -5, 1 times -5, 1 times -5. What's 4 times -5? -20. Okay. So I'm just going to put that there because that's what it would be if I multiplied it by -5. Yes? I don't want to rewrite the whole matrix again. So I'm going to add this to row 3. So -5 plus 3. -5 plus -4. -5 plus 5. There's that 0 I wanted. -20 plus 9. And then everything else stays the same. Okay. So I know where I want to be, and I go column by column. That is the way to make sure you don't lose zeros. The more comfortable you get with doing this, the more you can do things out of order. So the last row, the last column is looking okay. I got the 2 zeros I want, right? Let's move to the next column. How can I get a 0 immediately in that next column? Here. Does anybody just kind of want to die? It's terrible, Jeff. That whole. If I add row 2 and row 3 together, don't these make 0 here? I like it, maybe. Where do I want that 0 to show up? Here, right? So you keep this here in mind. So I want to do row 2 plus row 3. Does everybody see that? Because that would make a 0 here, correct? But I want to put the answer in row 3. Because then there'll be a 0 right where I want it. So row 1's not changing, correct? Row 1's not involved in this at all. It's like, all right, guys. Row 2's not changing. Row 3 is changing. What's row 2 plus row 3? 3 plus 3 is 6. 4 minus 4 is 0. 0 plus 5 is 5. 7 plus 9, 16. Okay, maybe. By the way, real quick, let's see if you guys are cool with this. Do you see how row 1, well, no, it doesn't matter. I'll leave it the same. I could make all these positive, right? All the negatives could cancel. But there's a reason I sort of don't want to do that, so we'll see. Okay. How are we doing so far? And again, I know this is brand new. This is brand new. I can see in some of your guys' eyes, you're all like, another frickin' thing. All right. But this is relatively nice. Once you get kind of used to it, I'm just trying to make zeros. So between these two, what do I need here? At the end?
0.
A 0, right? So I could, this is the same step we were at before, I could multiply this by 4 and this by -9 and add them together, correct? Okay. Or, well, let's do that. I think that'll be fun. Because I could multiply this row by 2, add these together, that'll make a -1 show up here. You guys see that? If I multiply this row by 2, I would get 6, 8, 14, right? -9 plus 8 is -1. I would get a 1. But let's go ahead and do this. Are you guys all with me? What would the LCD be between these? Wouldn't it be 36? So let me multiply the first guy by 4. 4 times row 1. And let me multiply the second guy by 9. And then I can add them together. That's going to make a 0. Do you guys see that? 4 times this, 9 times that, add them, that's 0. Where do I want that 0 to be? Which row do I want that 0 to be in?
Row
1. So I want to put the answer in row 1. So what is 4 times row 1? Let's see. -8, -36. 4 times 0 is 0. 4 times -11 is -44. So I'm just putting that there so I don't have to rewrite the whole matrix, right? What would 9 times row 2 be? 27, 36, 0. What am I doing with 9? 63. Okay, so let's see what we get. So 4 row 1. So if I add these together and put the answer in row 1, 27 minus 8 is 15. 36 minus 36 is 0. 0 plus 0 is 0. 63 minus 44, see, this is where, somewhere, oh, Jeff, I love you, dude, is 19, right? I believe, yes, okay. And here's where I'm probably gonna get a rebellion. You guys will understandably want some mutiny right now, because apparently, let me see if anybody can see why. Do you see why I know I made a mistake somewhere? Probably, when I put that together, I didn't stop and think about it long enough. What do I want right there? I want a 1 right there, right? How do I get a 1 right there? I divide by 15. If I divide by 15, what do I get here? I get a fraction, which is doable, but I don't want to do that. You guys kind of with me? All right, so I think probably when I put this together, you guys understand how I put this together? I had an answer in mind. So my answer was 1, 1, 2. 1, 1 is 5, minus 2 is 3. 1 minus 4, 3 minus 4 is -1, plus 10 is 9, so that seems to be okay. Did I write it down? 1, 1, 1, 4, 2, 3, -1, 3, 3, -4, 5, 9. Yes, that looks good. So we must have made a mistake here. Let's go back through. Oh, you guys are having the time of your life right now. Let's see. Then we did row 1 plus row 2, right? So 3, 4, 0, 7. That's good. Then we did -5 this plus this. So right. Wait. Oh, answer in row 1. -5 plus 3 is -2. -5 minus 4 is -9. -5 plus 0. -20 and 9 is -11. That looks good. Then we did row 2 plus row 3. Row 2 plus row 3 is 3 plus 3 is 6. 4 minus 4 is 0. 0 plus 5 is 5. 7 plus 9 is 16. That looks good. Then I did 4 row 1 plus 9 row 2. And I put the answer in row 1. Let's see. Oh, it's right there, Jeff. Holy shit. All right. So when you check your work, maybe go to the very last thing you did. Look at that number right there. that came from, what am I doing? 4 times row 1 plus row 2, correct? Plus 9 times row 2. Are you with me? What's negative 8 plus 27? 19. Okay. All right. Good job. Okay. So, but real quick, one nice thing that just happened. Do you see how easy it was for me to go back through my work? Because I told myself what the shit I was doing, right? If you don't write this and you go back to check your work, you're like, what did I do? Wait, what did I do? Holy shit, I gotta erase everything and start over. So if you write this, number 1, it helps you, number 2, it helps me. When I grade your work and you make a mistake and you don't write this, I don't know what the shit you did. So I have to take more points off. Okay. So let me see if you guys are with me. Why is that nice? What can I do with row 1? Well, in fact, what does row 1 say right now? What does row 1 say? 19x equals 19. So I can just divide by 19. So if I divide row 1 by 19, I get 1, 0, 0, 1. And then I still have 3, 4, 0, 7. And I still have 6, 0, 5, 16. Now real quick. We're almost there, guys. You're all like, we better be almost there, dude. What's the only column that's still not where it's supposed to be with zeros? There's only one column left to work with. First one. Do I have a 1 in that column? Yes. In fact, that 1, I can kill both of these, and these zeros won't screw with my other zeros. I don't know if you guys see what I'm saying. So what would I multiply this first row by if I want to kill this 3 here? Negative 3. Let's see if I can do 2 things at once. Let me start to show you some shortcuts. When I multiply row 1 by negative 3, maybe this is going to get messy. It already is messy, Jeff. Where can I put you? Oh, shit. Let's put you way over there. Put you there. Put you here. You know it's a good problem when you have to use multiple boards. So I want to do negative 3 row 1 plus row 2. Put the answer in row 2 so I can get a 0 right there. Negative 3 plus 3 is 0. 0 plus 4 is 4. 0 plus 0 is 0. Negative 3 plus 7 is 4. Now real quick, let me do 2 things at once so I don't write this damn matrix so many times. How would I kill this guy? What would I multiply this guy by to kill this guy? Negative 6. Okay. So I'm going to multiply by negative 6. 0 times negative 6 is 0. 0 times negative 6 is 0. 1 times negative 6 is negative 6. And then I add, so negative 6 row 1 plus row 3. Put the answer in row 3 because I want this guy to kill this guy. Make a 0 there, right? Negative 6 plus 6 is 0. 0 plus 0 is 0. 0 plus 5 is 5. Negative 6 plus 16 is 10. Oh my God. You see how I'm done? What do I do with this row? Divide by 4. What do I do with this row? Divide by 5. So I get 1, 0, 0, 1. 0, 1, 0, 1. 0, 0, 1, 2. So what's the answer? What's X? 1. What's Y? 1. What's Z? 2. So if you have it in this form, do you see how this can also be called diagonal form? Right? You have it in that form, you just read off 1, 1, 2. That's the answer. X, Y, Z. 1, 1, 2. Love you guys. Oh my God. See the excitement. I do have a handout that I didn't bring with me, but I'll post it up on Canvas. That's like a whole matrix problem, kind of like step by step done, so you can kind of have that to refer to, including your notes. One little thing, and then I'll let us out a little early, I think, because we all survived what just happened. Can somebody please interpret this system of equations for me? How many variables are there in that system of equations? Two, good. Are they necessarily x and y? No, I don't know, it didn't tell me. Can somebody tell me what this first row is as an equation? You could pick your letters. 2x? Minus 3y? All right, so the letters have been picked. So you can't pick them now. What's the second one say? 5x plus 4y equals -1. Cool, right? So you should be able to go back and forth between matrix form and system of equation form. And by the way, let me tell you one word you're going to see in the homework. This here looks like a square matrix, right? This looks like a 3 by 3. When I add in the solutions, this is officially called an augmented matrix. Anybody ever heard the word augmented? You hear that very often in like sci-fi movies where people are cyborgs. I have been augmented, right? They add components and shit, right? You know, Rick and Morty, Rick's got all these, he's augmented with all kinds of shit, yes? No? If you've never seen any of that, oh well, that's what the word augmented means. You add something on. So I have augmented this matrix with the answers. So you're gonna see that word in the homework most likely is write the augmented matrix. It just means write the coefficients with the answers attached. Is that okay? All right, I have sufficiently freaked you guys out. So I think that's enough. Did anybody not get their grade sheet summary? Everybody else is good? Everybody else is good? Okay. All right, guys. Have a good weekend.